Subject: Design of machine element. Practical number 10. Aim: to study about design of pressure vessel. The pressure vessel, for example cylinder or tanks, are used to store fluid under pressure. The fluid being stored may undergo a change of state inside the pressure vessel, as in case of steam boilers, or it may combine with other reagent, as in chemical plant. The pressure vessels are designed with great care because rupture of pressure vessel means an explosion which may cause loss of life and property. Classification of pressure vessel. First, according to the dimension. The pressure vessel according to their dimension may be classified as thin cell or thick cell. If the wall thickness of the cell T is less than 1 by 10 of the diameter of the cell B, then it is called a thin cell. On the other hand, if the diameter of wall thickness of the cell is greater than 1 by 10 of the diameter of the cell, then it is said to be a thick cell. Thin cells are used in boiler tanks and pipes, whereas thick cells are used in high pressure cylinder tanks, gun barrels, etc. Second, according to the construction. The pressure vessel according to the construction may be classified open end or closed end. A simple cylinder with a piston such as cylinder of pressure is an example of an open end vessel, whereas a tank is example of closed end vessel. In case of vessel having open ends, the circumferential or hoop stresses are induced by the fluid pressure, whereas in case of closed end, longitudinal stresses in addition to circumferential stresses are included. Induced stresses in a thin cylindrical cell due to an internal pressure. The analysis of stresses induced in a thin cylindrical cell are made on the following assumptions. First, the effect of curvature of the cylinder wall is neglected. Second, the tensile stresses are uniformly distributed over the section of the walls. Third, the effect of the restraining action of the hairs at the end of the pressure vessel is neglected. When a thin cylindrical cell is subjected to an internal pressure, is likely to fail in the following two ways. First, it may be fail along the longitudinal section, for example circumferentially splitting the cylinder into 2002 through as shown in figure A. Second, it may fail across the transverse section, for example longitudinally splitting the cylinder into two cylindrical cells as shown in figure B. Here two figures are shown. First, failure of cylindrical cell along the longitudinal section. Second, figure B is shown failure of cylindrical cell along the transverse section. Thank you.